at modeling exponential functions. So we're going to see some word problems here. And so the warm-up question, the first one says, the equation that represents exponential growth and decay is y equals a times b to the exponent x. And then it says, what do each of the variables a, b, and x represent? Now, if we think back to lesson 1 where we did some investigations on exponential growth and decay, we looked at modeling Canada's national debt as an example of exponential growth, and we looked at population changes over time as an example of exponential decay. And so we're going to look at what each of these variables represent, and we're going to look at a few real-life examples that also look at exponential growth and decay, but you'll notice that the equations will be slightly different for the examples we're going to look at in a few minutes. Okay, so starting with the variable a. So if you remember from way back when, a represents the initial value of the concept that or the data that we're looking at. So this is the initial value. B represented the growth or decay ratio. So it depended on whether it was more than 1 or less than 1. If it was more than 1, it was a growth. If it was less than 1, it was a decay. It was a ratio. So that was also the number that you would have to multiply by each time to get to the next value. And the way we found the growth and decay ratio, aside from using the table of values, is that it was actually related to the growth or decay rate. Oh, that's my lead. There we go. So the growth or decay ratio can be found by adding 1 plus or minus the growth or decay rate. Okay, and the rate was a percentage value. Okay, so the rate that we were looking at was a percentage value. Okay, and the last part is x. X represented the number of growth or decay periods. Or in other words, let's say every year a population decreased by 10%. So then what that means is in 5 years there's been 5 decay periods. Every year it decays 10%. So this happens 5 times over a span of 5 years. We're going to look at questions that are slightly different. We only looked at annual problems when we looked at it in lesson 1's investigations. Now we're going to see what happens if it's not happening on an annual basis. We're going to see what happens if it happens twice a year, or if it happens every 3 years, or every 3 hours, which is the example that we're going to see in the second part of the warm-up.